Okay, today we're going to be doing multiplying and dividing radical expressions. So obviously we need to make sure that we know multiplying radicals, they have to have the same index, dividing radicals, same index. And we always have to rationalize the denominator, which means no radical in the denominator. Okay. So when we're looking at this, when we simplify, we always want to simplify before we even multiply or divide, which means anything that can come out needs to come out. And also for multiplying or dividing, we were always going to do outside with outside, inside with inside, right? So that means the radicand is going to be multiplying with the radicand, and the radicand can be dividing by the radicand, right? And then we always simplify. Now, when we do all these things, it's very important that the radicals must have the same index, right? In order to multiply or divide, they have to have the same index. If they don't, then there's nothing that you can do. Okay, here we go. Well, speaking of the same index, yep, we do. We have the same index, right? So we always want to simplify if we can, right? So right now, when we're looking at this, we see that a -4 is -1 times 4, right? Now, a negative can always be taken out of an odd index. It can't be in an even index, but an odd index it can, okay? So under here, we'll have a -1 coming out. And the reason is because -1 is made by a -1 times a -1 times a -1. So you can see how a -1 can come out. But we're not going to write that down every time. We're just going to take the -1 out. And nothing else can really come out in this one. And so this is what we start with. Now remember, when there's nothing on the outside, there's just a 1, right? So when we do the outside with the outside, we'll end up to get a -1. And then the inside with the inside, we will have the cube root, and we'll have 3 2's inside. Well, that works wonderful because our index is 3, so we needed 3 to come out. So we take this 2, multiply by this -1, and we get a -2. So that is the simplest form of this one. Okay, on the next one, we can see that the index is the same, right? So our index is 2 because there's nothing there. We don't have anything on the outside, so we can pretty much put this all under 1, but let's go ahead and simplify first. So 72 is made by 8 and 9, so that is 3 2's and 2 3's, right? And then 10 is a 2 times 5, so we really can't take anything out of that. Now, if we look at everything else here, we are going to be able to take one of these out, and we are going to be able to take an x out, because you can see how if we have 3, we can take one x out, and if we have 2 y's, we can take a y out. Now here's the deal. If it says assume that all variables are positive, you don't need absolute value. So if your direction says assume all variables are positive, you don't need absolute value. Okay, but if it doesn't, you're going to want to put the absolute value. And we just have simplify here, so we're going to keep going using the absolute value. But I'm going to show you like everything put together because there's really nothing on the outside. Let's just put everything in the inside. So we have 4 2's. We have 2 3's. We have 1 5. And then we're going to have 4 x's, which means I'm not going to take everything out until the end. Now, I don't really recommend this, but I'm just showing you if you did it instead of simplifying first. So we have 5 y's. Okay, so let's see what we can take out. Since the index is 2, we need pairs of 2. So this is 2 times 2 times 3. The 5 will stay in. And then we have an x times x. And we have a y times y. And we'll have a y left over. So we would have something that looks like a 5 left over and a y left over. Now, 2 times 2 is 4, times 3 is 12. So we have 12. And then this is x squared, so we wouldn't need an absolute value. And this is y squared, so we wouldn't need an absolute value. And we're done. If those were odd indices, then we would have to have an absolute value because it didn't say assume that they're all positive. Okay, let's go to the next one. Now, with square roots, what I like to do with the square root is I like to kind of, if there's two separate ones, like one on the top and one on the bottom, and I see that they have something in common, I'm going to definitely put them under one roof and simplify out. So we have 18x to the fifth over 2x cubed. Well, we can see that the 18 and the 2 have a 2 in common. So we'll end up with a 9 on the top. And we have more x's on the top than we have on the bottom. So we'll end up with just x squared on the top. And there's nothing on the bottom, right? So we're just going to end up with the square root of 9x squared. Well, that means a 3 comes out and an x comes out. Well, the 3 comes out is great, but the x coming out, we're not sure if it's positive or negative, and it has an odd index. If it was even, anytime we take something and square it, right, it's already going to be positive. But when it's odd, we're not sure if it's positive or negative. And so since we're taking the principal square root, because it's just positive in front, we're not going to be able to have a negative. So that's why we have the absolute value. So 3 absolute value of x. Okay, let's look at the next one. So we look inside and we see that they both have y's. Even if we didn't know that there's a value in common, we would see that they both have y's. So we're going to put them under the same roof. And so we have 162, and then we have y to the fifth over 3y squared. Okay, so we can see that they have the same base. So we have 3 more on the top. So right off the bat, we're going to have y cubed on the top, but no y on the bottom. Now, let's see if there's a 3 in 162. Well, divisibility rules for 3 says if I add the individual numbers, and that is divisible by 3, the number is divisible by 3. So since this is 9, this is definitely divisible by 3. So let's go ahead and take this and divide it by 3. 3 goes into 16. 5 times, and there's our 4. So this is 3 times 54. So we can take a 3 out of both of these and we'll end up with 54. And again, we don't have anything left on the bottom, so it's 1. So now we just have the cube root of 54y cubed. Well, 54, when we break it down, is 9 times 6. So this is 3 times 3 times 3 times 2. That gives us 3's that are going to be able to come out and a 2 that stays in. So if you can't see that, we can rewrite it. So we have 3 times 3 times 3 times 2, and then I don't want you to continue to write these out. I need you to be able to see this. So we would have a 3 coming out and a y coming out. Now, the index is odd, so we don't need an absolute value. And then we're left under the same index with a 2. And that would be our solution. Okay. Let's keep going. Now on this one, as we look at this one, the 5 doesn't have anything in common with the 12. The x squared doesn't have anything in common with these guys. So we're not going to keep this under one roof. We're going to put it under 2. So now we're going to go backwards, right? We're going to go the other way. So we'll have the cube root of 5, x squared, and then we'll have the cube root of 12y squared. Well, we obviously can't have a radical on the bottom. So we need 3 to get 1 out. But before we do anything, we're going to break this down. So 12 is 3 times 4, which is 2 times 2. So let's see what this looks like. So on the top, we still have this. Nothing can come out. But on the bottom, we have a 3 times 2 times 2, and then a y times y and a z. So in order to get this out of the exponent, the radical, we need 3 of the same thing. So we only have, so we use the same index. Let's move this down a little bit. I'm kind of making this way too big. So we only have 1 3, so I need 2 more. We have 2 2's, so I need 1 more. We have 2 y's, so I need 1 more. And we have 1 z, so I'm going to need 2 more. So I'm going to be multiplying the top and the bottom by, this is 9 times 2, so this is 18 yz squared. So when we do this, everything's going to come out of the bottom here because we're going to be taking a 3 out. We'll take a 2 out. We'll take a y out and a z. So this guy will be 6yz. Now on the top, we don't have anything that we can take out. So we're going to just leave everything inside. So we'll have 5 times 18. And then x squared yz squared. So we'll take 5 and 18, and we'll get 90, right? So we have the cube root of 90 x squared yz squared. Now, these are inside and these are outside, so we can't simplify this at all. Okay, so we're finished with that one. Yay, okay. And remember, we didn't need absolute values because this is an odd index. Okay, so again, we have some inside and some outside. So if we were looking outside, we have 3 and 15. Well, obviously they both have a 3 in them. So we will turn this into divide by 3, we get 5, divide by 3, we get 1. Okay, now we're gonna look on the inside. So when we look on the inside, we can definitely see that something's in common, right? So let's see what we have in common. If we were looking on the inside, I'm just gonna like pull them out right here. So 60x to the 5th over 12x. That means they can both be put under the same radical. So 60 divided by 12 is gonna give me a 5. And then we have more x on the top, so we'll be left with 4x on the top. And so we actually turn this into 5 is still on the outside, but we have a 5 on the inside and then an x to the 4. Now, we still need to take that x out because this is essentially x times x times x times x. So you can see how we're going to be able to take 2 of the x's out. So this is 5 times x squared, and we have an even index, but we're taking an even value out, so we don't have to worry about it. And there's our solution. Okay, I hope this helped. Have a good day.